Let us understand the ray diagrams for convex lens. To understand the ray diagrams, so we have taken a convex lens here. This is the principal axis of this convex lens, and this is the focal point or focus, and the distance from the optic center to focal point is called focal length. This is 12 centimeters, and this is also focal point. This is the center of curvature, and this is one more center of curvature of this convex lens. Now let us place this is object. So let us place this object at various distances in front of the convex lens. For example, first let us place the object at beyond center of curvature, then at center of curvature, then between focal point and center of curvature, then object is placed at focal point, then object is placed between P and focal point. Then we observe the various types of images and nature of the images. Now object is placed at beyond the center of curvature. So let us draw the ray diagram when the object is placed beyond the center of curvature. See, a ray is parallel to the principal axis after refraction. So it is passing through the focus, and let us take the second ray. Observe the second ray. The second ray is passing. So it is, this is the object, this is the object. So ray is passing through the optic center. These two refracted rays meet at this point. The second ray, see here, passing through the optic center, we know that it is undeviated. So this ray, so carefully observe, these two refracted rays meet at this point. We get the image of this object at this point. So observe here. So here these two refracted rays converging. So the size here we are getting the image. That image is diminished image, inverted image, and a real image. Now let us keep the object at center of curvature. First ray is passing parallel to the principal axis. So after refraction, it is passing through the focus. It is passing through the focus, and the second ray we are taking this, the ray which is passing through the optic center. It is undeviated. So observe here, these two refracted rays, this ray is passing through the second ray. This is the second ray. It is passing through the optic center. So observe the refracted rays. See here, exactly the refracted rays meet at center of curvature. Observe this one, see, observe this one, this ray, see, it is passing through this optic centers. So this is first incident ray, this is second incident ray. The first incident ray after refraction passing through the focus, and the second incident ray passing through the optic center, and it is undeviated, and these two refracted rays meet at this point. Observe carefully. Right. So here the size of the image is equal to the size of the object, and that is a inverted image and a real image. Now let us place the object between F2 and C2. Parallel ray passing through the focal point, the second ray, observe here. The first ray, second ray after refraction, observe here. These two refracted rays converging. These two refracted rays converging beyond the center of curvature. So these two refracted rays converging beyond center of curvature. See the size of the image like this. Okay, size of the image is larger than the object, and it is inverted image and a real image. When the object is placed between focus and center of curvature, see the refracted rays converge beyond the center of curvature. So at there the image will be formed. That image will be larger than the object, inverted and real image. Now let us place the object at F. This is the first ray passing through the focal point, and the second ray, see second ray is moving from the object to optic center. You observe here, after refraction, these two refracted rays, so they are parallel to each other. They are parallel. It means they converge at infinity. So the image will be formed at infinity. After refraction, these two refracted rays are parallel to each other. They will meet at infinity distance. So the image will be formed at infinity distance, and the nature of the image is inverted and real image and larger than the object. Next, let us keep the object between P and F. So first ray parallel to the principal axis after refraction. See here, it is passing through the focal point. The second ray, so passing through the optic center, from the object to optic center. Observe here. So this is a second ray. It is undeviated after refraction. So it is undeviated light ray. Observe, they are diverged rays. These two refracted rays appeared as diverging from a point behind the lens. So these two refracted rays diverging from a point behind the lens. So in this case, image will be formed behind the lens. In this case, image will be formed behind the lens and the same side of the object. These are the refracted rays for convex lens.